Welcome to this RTInsights conversation with Acceldata on data reliability and how to deliver data on time at the highest possible quality. I'm Helen Beal, and today I'm talking with John Morrell. So John, with data volumes proliferating at such a dizzying rate, what are the characteristics of cloud data platforms that help people access the value from their data that leads to those better decisions that we all want?
Well, the real value of cloud data platforms is in that it provides organizations with a much more sort of agile approach to managing their data, as well as delivering it to analytics and business teams. You can spin up resources on demand with cloud data platforms, and you only need to use the resources as they are needed. So again, this helps deliver all this agility. So again, the result of using a cloud data platform or even migrating to a cloud data platform is you get much more agile data teams and processes. You can deliver new analytics projects and data much more quickly. And that facilitates greater consumption of use of data within the business. That's the whole data democracy thing, right? Cloud data platforms give you the ability to facilitate much more data-driven decisions and the ability to proliferate data throughout the business.
So you mentioned data democracy. Could you explain for the audience what that means?
Well, data democracy is really about trying to let more people use data, right? And also let people access more data. Now, it doesn't have to be data in its rawest form. It can be data that's been curated for them, right? But the ability to proliferate data democracy throughout the organization is to make sure that when somebody makes a decision or decides to take a certain action, that they're actually backing it up with data and that they have all the right data in front of them so that they can move quickly.
So we've got all this wonderful data, and then we've got all these wonderful people that want the data. How do we get the data from where it is to those people?
Well, that's typically something called a data pipeline, right? And at its basic level, right? A data pipeline works its way across what we call a modern data stack. And I'm sure you're going to ask me in a minute what a modern data stack is, right? But it exists of components that one takes sort of like the raw data from all these applications and other sources, and then tries to land it in either a cloud data warehouse or a lakehouse, one of these cloud data platforms we just talked about, and then transform that data into some sort of form that's useful for analytics. I used the word curated just a few minutes ago, right? Curated data that an analytics person can use and work with and then stop and say, oh, I can know how to find the answer. And then deliver this data to the actual analytics tools or other applications so it can be actually consumed. Within a data pipeline, data assets really come in multiple forms, right? It's sort of data at rest, data in motion, as well as data to be consumed. And it comes from sort of like the raw data from the data sources. It's data that's moving through pipelines. It's data in the cloud data warehouse. That's data in the cloud data warehouse that's transformed already. And finally, the end analytic data sets. So data assets get proliferated in this process because they're going through many different forms within a data pipeline.
Wonderful. And you did mention the modern data stack. So maybe you want to define that perhaps from what a traditional data stack looks like.
Right. So a traditional data stack in sort of your on-premise world really focused around, you had your sort of source data. You would have a data integration platform or ETL platform, but then it would make some certain stops along the way in terms of, into data warehouses or databases as it was being worked on. And then finally, it would get delivered down to either a data warehouse or a data mart. In the more modern sort of cloud world, you have what's known as data loaders, which take data from the raw. It takes data in its raw form from the applications and will deliver it into a cloud data warehouse. Then once it's in the cloud data warehouse, it will get transformed with transformation tools. And then you've got sort of like, once it's transformed, it's in a consumable form. right? And then from there, and that resides in the cloud data warehouse. And then from there, the analytics tools can access it and work with it. There's also things like orchestration tools that can kind of orchestrate your data pipeline. And then there's also data observability tools like Acceldata that help you sort of monitor and manage everything that's going on here.
Now, I do always like to make sure we clarify what acronyms are that we use. And you mentioned ELT, which is extract, load, transform. And I think one of the fundamental differences you've just described with the old and the new is that we used to ETL, extract, transform, load, and now we're ELTing, extract, loading, transforming. Is that the right way around?
Correct. So again, a modern data pipeline is really more of ELT, as you mentioned. And they use these pieces of the modern data stack in order to sort of work its way through that process. And again, it's hopping between a variety of platforms and tools as it sort of goes through this pipeline. And this is what adds a little bit of the sort of complexity to the modern data stack, right? And the modern data pipelines is the fact that you're really now hopping around between more places and more tools. And it's difficult to get sort of like this one big visibility into what's going on with all of that. And so there are some tools that can come with your cloud data provider or other things, but really what you need and what people are looking for from data observability tools is to give them that visibility across that entire sort of set of components within the modern data stack. And then going to things like multi-cloud or even hybrid cloud further exasperates this because, again, the data is more spread out. It's in different places. It's in different clouds or different, even on premise. So you need to be able to, get the singular view of everything across your sort of entire modern data stack.
Now, you've mentioned observability a couple of times. Let's talk about unknown unknowns and silent failures. What are the causes and the nature of these things, and how can teams prevent, avoid, and remediate these things happening to them?
Okay, silent failures is a great term, right? It's in our world, it's when data problems occur, but nobody knows about it, right? The data team doesn't know about it. The data engineers don't know about it. The only time they find out that something bad happened is when somebody in the business is out screaming, saying, "Where's my data?" Right? And this could be a number of different issues. It could be things like issues with data quality. It could be issues with the data pipelines because they're just not executing properly or taking too long to execute. You could have data schema problems, or even what we like to call data drift, which is when data sort of goes beyond the normal bounds of what you'd be expecting in this. And then if your data pipelines are having problems, you have got sort of data timeliness or data freshness issues. So data teams can use tools and platforms such as data observability ones like ours to help prevent and avoid these problems because they get this insight into the problems. They can get alerts when problems occur, but then they can also dig into the data and remediate what's going on, immediately fix the problem quickly. And so a platform such as a data observability platform really, one, it provides this complete visibility into the assets in the data pipelines. It allows data teams to really apply data quality policies at scale across all of these data assets, right? Again, the data teams get alerts to problems when they happen, so they can, one, they know they happen, so there's no silent failures. They know when problems occur. And a good data platform, a good data observability platform will really also give you this sort of deep multi-layer set of data, because it's not just enough to know that a problem occurred, right? You really need to be able to dig into the data and say why the problem occurred and help resolve the problem, right? If a problem occurred because a data pipeline was taking too long, well, you need to understand why that happened. Perhaps you didn't have enough sort of compute resources allocated to the data pipeline at the time, or some of your compute resource went away, or there was too many other things banging away at the cloud data warehouse at the time, right? So you need to be able to stop and correlate data like compute with failures. and help you sort of understand, oh, this is why it happened. I'll make sure this never happens again, right? And then you can also facilitate these automated responses to everything in order to just let the problems get fixed by themselves.
So these are exciting times. It's always a trade-off, isn't it? On one side, we've got this really rich data, these rich platforms and architectures, but with it, we've got volumes and complexity. So for people that are coming into this new, where do teams typically have blind spots where it comes to data? And what are the big gotchas that they need to watch out for when they adopt these new cloud data platforms?
Yeah, so we see probably 6 key places where they've typically got these blind spots. One is just in performance. It's in throughput. It's in latency. Do I have enough resource allocated to make sure that this pipeline gets executed properly? And is it taking too long? This is very typically a blind spot. Second is in what we like to call data quality, right? And data quality has been around for a long time, and there have been tools around that do it. But with more and more data and more complex data formats and more movement of data, data quality takes on a whole different aspect to it, right? We have something that we like to call shift left, which means you can shift all the way left to the source of a set of data, figure out whether or not that data is of the highest degree of quality, right, or meets the quality standards. And if there's a problem, then we can isolate it immediately before it even starts to go through the rest of the process, before it even gets into the data warehouse, and then remediate it and then fix it and then keep things moving from there. There's also things around what I would call data reconciliation, which is where as data moves, you maybe will stop and say, hey, wait, this data isn't matching up with this data. The data I've got in this particular column doesn't match with the column where it came from or something like that, right? And so you need to be able to stop and reconcile what's going on with the data. Executing in a timely manner so that the data gets delivered. There's also what we like to call schema and data drift, right? Schema drift is when the schema, the upstream schemas tend to change. And then that has a ripple effect all the way through the data pipeline if that changes, right? And then there's also data drift, which I mentioned before, which is where suddenly data that you have goes completely out of the bounds that you would typically expect, or out of the distribution, right? If you've got a data set that's got a region field in it, but all of a sudden during one pipeline execution, there's nothing from Europe, right, in there. Well, that means that data's gone way out of the bounds and something went wrong, right? And then the other key aspect, the other key blind spot a lot of people have is in the performance and costs of their cloud data platforms. There's a number of instances we've heard where people just sort of like let their sort of cloud data warehouse loose without really knowing what the costs are going to be like. And data teams and then business teams and analytics teams start pounding away at it, and they don't know what's going on with costs. And then they get the bill at the end of the month and they look at it like, wow, how did this happen? Right? So because cloud data warehouses are somewhat new and have the ability to spin up resources on demand or scale as they need to, they're elastic, then the problem you have is you could end up sort of just going too elastic or applying too much resource at a particular point in time. And you want to be able to understand what's going on there in order to eliminate that blind spot.
Perfect. So to recap from the audience, the top 6 things to keep your eye out for: 1, latency; 2, quality; 3, reconciliation; 4, pipeline health; 5, schema and data drift; and finally, performance and cost at number 6. So we've got time for one more question, I think. The world is increasingly regulated. I think organizations are feeling this all the time. So what do data governance teams need to do to ensure that their organization is compliant with these ever-changing regulations? And how can they ensure adaptability, because they're constantly changing?
Sure, and these regulations constantly change as well. I've been, looking at data governance stuff for the past probably 8 years of my career, both here at Acceldata and my previous companies. And it just continually gets more and more complex in order to figure out how to govern your data. A lot of people associate data governance with just sort of making sure data is secure. But there's another key aspect of data governance, right? Which is the ability to monitor the data. And that means, how is it used? Where is it sent? Where does it move to? Who is consuming it? Is the data up to date? Does it have like a high set of quality to it? So data governance is getting more and more complex because there's a lot of other things that data governance teams need to look at, just besides, hey, is the data over in this one place and is it secure and only the right people are seeing it, right? It's really all more these days about where's the data moving to and how is it being consumed and how is it being used. And if you're lacking any of these aspects, then the data can easily come out of compliance, come out of regulatory compliance, and all of that might be at risk. So that's, again, another place where data observability doesn't give you a full data governance sort of view of things, but it helps with data governance by giving you the ability to understand where your data is moving to, how it's being used, and how it's being consumed.
Perfect. Well, this has been an extremely interesting and very pertinent conversation. I particularly enjoy talking about lake houses as well. They're a nice new word. I think it's just emerging at the moment. So thank you very much for your time, John. Thank you everyone for listening, and see you again some other time.
Thank you.